Λοιπόν, συνάδελφοι, καλημέρα. Με την παρούσα εκδήλωση, ο Πανελλήνιος Σύλλογος Διπλωματούχων Αγρονόμων Τοπογράφων Μηχανικών βεβαιώνει για άλλη μια φορά τον επιστημονικό του χαρακτήρα. Το σεμινάριο αυτό αποτελεί επί της ουσίας τον επίλογο μιας σειράς σεμιναρίων που αφορούσαν θέματα κόμβων. Και απλά σε αυτό το σεμινάριο, όπως θα σας πούν και οι συνάδελφοι που θα μιλήσουν μετά, μπαίνει η ευρωπαϊκή διάσταση του θέματος. Ο Σύλλογος δεν σταματάει εδώ πέρα. Επενδύει στη συνεχιζόμενη εκπαίδευση. Προτιθέμεθα στο μέλλον να οργανώσουμε νέους κύκλους σεμιναρίων πάνω σε θέματα πράξεων εφαρμογής και σύνταξης τοπογραφικών διαγραμμάτων. Και αυτή είναι μια πρώτη απάντηση που δίνουμε κόντρα σε όλους αυτούς που επιδιώκουν την απαξίωση του επαγγέλματος του μηχανικού. Δεν θέλω να πω περισσότερα για να μην σας κουράσω. Θέλω να ευχαριστήσω όλους εσάς που είστε εδώ πέρα σήμερα μαζί μας, τους συζητητές μας, τους ανθρώπους από το Σύλλογο που πάλεψαν και αγωνίστηκαν για να γίνει αυτή η εκδήλωση, τον συνάδελφο τον Γιάννη τον Πρέσβελο και τον Πέτρο τον Παπαθανασόπουλο, και φυσικά τον καθηγητή μας από το Πολυτεχνείο, τον κύριο Ψαριανό. Καλή παρακολούθηση.
Καλημέρα αγαπητοί συνάδελφοι και από μένα. Επειδή κατά καιρούς ασχολούμαι αρκετά χρόνια με το συνδικαλισμό και κατά καιρούς έχω καταλάβει ότι οι συνάδελφοι δεν καταλαβαίνουν τι κάνει ένας σύλλογος και μάλιστα με ένα περίεργο χαρακτήρα, κάπου επιστημονικός, κάπου συνδικαλιστικός, για να τους βοηθήσει. Με αποτέλεσμα να μην στηρίζουν τους συλλόγους, γιατί δεν κάνει κάτι πολύ άμεσο για αυτούς. Από την εμπειρία μου, ο Σύλλογος Τοπογράφων έχει κάνει μια φοβερή προσπάθεια, όχι τώρα, πάνω από 30 χρόνια, και γι' αυτό έχει μπορέσει να ανεβάσει πολύ ψηλά το επίπεδο των τοπογράφων. Ενώ μέσα στην παραγωγική διαδικασία. Θεωρούμε λοιπόν υποχρέωσή μας να αναφέρουμε και λίγα πράγματα σχετικά με αυτά τα οποία σας είπε ο πρόεδρος προηγουμένως για την εκπαίδευση. Να θυμίσω ότι την περασμένη Παρασκευή ψηφίστηκε στη Βουλή ο νόμος ο οποίος καταργεί τις ελάχιστες αμοιβές των μηχανικών. Και μάλιστα όχι απλώς καταργεί, σε ακραία περίπτωση προβλέπει να γίνονται και τσάμπα δουλειές. Πριν από τσαμπαμελέτες, πριν από 2 μήνες περίπου, το Τεχνικό Επιμελητήριο είχε κάνει μια εκδήλωση, μια ημερίδα. Είχε φέρει από το εξωτερικό συναδέλφους για να δούμε πώς δουλεύουν τα συστήματα των αμοιβών εκεί. 2 από τα σημεία τα οποία χρησιμοποιούσαν πάρα πολλοί συνάδελφοι για να τεκμηριώσουν τις αμοιβές ήταν συνεχιζόμενη εκπαίδευση και ποιότητα. Η συνεχιζόμενη εκπαίδευση στην Ελλάδα έχει σοβαρά προβλήματα, θα έλεγα ότι είναι ανύπαρκτη, με την έννοια ότι δεν είναι καταρχήν κατοχυρωμένη. Ο Σύλλογος, όπως και άλλοι φορείς, κάνουν ημερίδες σαν και αυτοί, διημερίδες, εσπερίδες, διάφορα προκειμένου να βοηθήσουν τους συναδέλφους. Όμως το 2009 ο Σύλλογος αποφάσισε να κάνει μια κίνηση παραπάνω. Έτσι, τον Νοέμβριο του 2009 προχωρήσαμε σε ένα εκπαιδευτικό σεμινάριο το οποίο είχε διάρκεια 5 ημέρες, από 8 ώρες την ημέρα. Και φυσικά έχει και έναν άλλο κόστος, τελικά το κοστολογήσαμε 800 ευρώ στη συμμετοχή του καθενός. Το σεμινάριο αυτό αφορούσε τους ανισόπεδους κόμβους, όπου είχαμε επισημάνει ένα έλλειμμα στη γνώση. Ο κύριος Ψαριανός είναι αυτός ο οποίος, σε όλα αυτά τα οποία σας πω, είναι ο κύριος επιστημονικός συνεργάτης του Συλλόγου. Να επισημάνω εξ αρχής ότι ο κύριος Ψαριανός δεν συνδικαλίζεται, είναι καθηγητής στο Πολυτεχνείο και όπου θα δείτε το όνομά του είναι δωρεάν. Ούτε καν στο βιογραφικό του δεν ξέρω να γράφω για αυτά. Εν πάση περιπτώσει, όσον αφορά τους ανισόπεδους κόμβους, φέραν ίσως ένα από τους καλύτερους Αμερικάνους μελετητές, όχι καθηγητή, μελετητής ήταν, και ο οποίος είναι και βασικός συγγραφέας του χειριδίου των ανισόπεδων κόμβων, του Ινστιτούτου of Transportation Engineers. Είχα είχαμε πολλές αγωνίες. Οφείλω να σου το πω. Γιατί ναι, δεν ξέραμε ότι ο άνθρωπος είναι καλός στη συγγραφή, αλλά δεν ξέραμε αν οι συνάδελφοι όταν φεύγανε από αυτό το σεμινάριο θα ήταν ικανοποιημένοι. Οι συνάδελφοι ήταν ενθουσιασμένοι. Και αυτό μας έδωσε πολύ δύναμη. Επιπλέον σε αυτό το σεμινάριο καταγράφηκε και μία ανάγκη για ισόπεδους και κυκλικούς κόμβους. Roundabouts. Προχωρήσαμε λοιπόν στην επόμενη ιστορία, στην επόμενη διοργάνωση. Εκεί είχαμε ένα θέμα. Τι να φέρουμε, Αμερικανούς ή Ευρωπαίους. Αποφασίσαμε λοιπόν το εξής. Πρώτον, κάναμε ένα σεμινάριο 6 μέρες με τους Αμερικανούς, όπου ξεκινήσαμε από το Α και φτάσαμε στο Ω. Αλλά οπωσδήποτε στην Αμερική έχουν και κάποιους άλλους χώρους, κάποιες άλλες διαδικασίες. Και εξ αρχής λοιπόν προγραμματίσαμε ότι θα κάνουμε και μια ημερίδα σαν τη σημερινή. Για τον κύριο Ψαγιανό σας τα είπα. Στο σεμινάριο ήταν 2 εισηγητές, ο κύριος Λύς και ο κύριος Ρόντετζερς, κυρίως διότι θέλαμε να βρούμε πάντα την καλύτερη λύση. Και επομένως θεωρήσαμε ότι ένας εισηγητής δεν ήξερε απόλυτα ή για τον καλύτερο τρόπο για μας και ισόπεδους και κυκλικούς κόμβους. Επίσης, σε αυτό το σεμινάριο κάναμε και μια άλλη καινοτομία. Κάναμε εξ αποστάσεως εκπαίδευση. Για να δοκιμάσουμε πώς δουλεύει αυτό το σύστημα. Συγκεκριμένα 2 προγράμματα, το ένα ισόπεδο κόμβων και το άλλο κυκλικών, έγινε παρουσίαση από την Αμερική και όσοι φοιτούσαν στο σεμινάριο κάνανε ερωτήσεις, λέγανε απορίες. Αυτό ελπίζουμε να το αξιοποιήσουμε και στο μέλλον. Και φτάσαμε στο σημερινό σεμινάριο, δεν θα καθυστερήσω γιατί είμαστε ήδη λίγο πίσω. Θα σας πει παραπάνω και ο κύριος Ταριανός και θέλω να μείνω σε ένα τελευταίο σημείο. Από το 2001 έχουμε ξεκινήσει μια διαδικασία ενημέρωσης του επιστημονικού κόσμου της Ελλάδας σχετικά με τη διαχείριση των προσβάσεων. Το 2001, λοιπόν, κάναμε μια επιστημονική διημερίδα παρόδιας χρήσης και υγιής και διαχείριση προσβάσεων. Βγάλαμε και ένα βιβλιαράκι σε αυτό το πράγμα, με όποιες συγκλήσεις υπήρχαν. Και προχωράμε τώρα, τον Ιούνιο, στο πρώτο παγκόσμιο συνέδριο. Η διαχείριση των προσβάσεων δουλεύεται πάρα πολύ στην Αμερική και σε άλλες χώρες, αλλά κυρίως στην Αμερική έχουν γίνει 10 συνέδρια. Το πρώτο παγκόσμιο συνέδριο γίνεται στην Ελλάδα. Έχουμε ξεκινήσει τη διαδικασία περίπου 3 χρόνια. Διοργανωτές είναι ο Σύλλογος Τοπογράφων, είναι η Επιτροπή Διαχείρισης Προσβάσεων του Αμερικάνικου Transportation Sales Board και είναι και το Τεχνικό Επιμελητήριο, στο οποίο κάναμε ένα αίτημα να δημιουργήσει μια επιτροπή. Γιατί? Καταρχήν θέλαμε και τα Υπουργεία, όπου πραγματικά το Υπομεδί έχει ορίσει έναν εκπρόσωπο, υπάρχει ένα θεματάκι, αλλά θα ξανορίσει, και το ΕΠΕΚΑ θα μας ορίσει αυτή τη βδομάδα, μάλλον τον έχει ορίσει, δεν έχουμε πάρει το χαρτί του. Το κυριότερο όμως είναι επιστημονικό. Και επομένως στην Οργανωτική Επιτροπή συμμετέχουν και εκπρόσωποι από τους πολιτικούς μηχανικούς, τους αρχιτέκτονες, τους χωροτάκτες είτε σε ΕΠΟ είτε τους περιφερειακής ανάπτυξης και ο ΣΕΣ. Νομίζω δεν ξέφυγε. Δεν θα καθυστερήσω γιατί φαντάζομαι ότι θα τα πει ο κ. Ψαριανός. Είναι μία μέρα ένα workshop το οποίο είναι ιδιαίτερα σημαντικό, διότι θα ξεκινήσει από την παρουσίαση τι είναι και θα φτάσει στην εφαρμογή και διαχείριση των προσβάσεων. Να μην μείνω εδώ, έχει 5 ενότητες που θα τα πει ο κ. Ψαριανός. Και συνέχεια υπάρχει ένα συνέδριο 3 ή μάλλον 2,5 ημερών, αρχίζει Τετάρτη, τελειώνει Παρασκευή ή μεσημέρι. Την επόμενη εβδομάδα θα βγει και το αναλυτικό πρόγραμμα. Σας δίνω το περιληπτικό πρόγραμμα, τα οποία όλα αυτά θα τα βρείτε και στο ίντερνετ, το οποίο έχει 8 ενότητες. Αυτό το οποίο θα ήθελα να σας πω είναι ότι μέχρι 31 Μαρτίου υπάρχει η εγγραφή έχει μια έκπτωση. Και επομένως θα σας παρακαλούσα να παρακολουθήσετε από το site αυτή τη διαδικασία, ώστε αν σας ενδιαφέρει να το παρακολουθήσετε και να το στηρίξετε. Να πω ότι, επειδή εδώ πέρα έχετε κάτι νούμερα 4 εκατοστάρικα κτλ., να σας πω ότι ό,τι χρήματα παίρνουμε και από τη σημερινή εκδήλωση πηγαίνουν μόνο για τις εκδηλώσεις και πουθενά αλλού. Σκεφτείτε ότι σήμερα, δεν ξέρω πώς θα έρθουν τελικά, έχουν δηλώσει 130 άτομα συμμετοχή σκεφτείτε όμως ότι αυτή η διαδικασία που κάνουμε εδώ κοστίζει γύρω στα 8 με 10.000, λέει το συγκεκριμένο το επιδοτούμε κιόλας. Αλλά δεν είναι δυνατόν να κάνουμε σοβαρή εκπαίδευση, δυστυχώς, χωρίς να πληρώσουμε ανθρώπους. Αυτή είναι η διεύθυνση που μπορείτε να μπείτε και να το δείτε, και από το τεχνικό επιμελητήριο μπορείτε να δείτε αυτή τη διαδικασία. Αυτή είναι η πρώτη σελίδα. Εγώ αυτό το οποίο θα ήθελα να πω τελειώνοντας είναι το εξής. Είμαι απόλυτα βέβαιος ότι όταν τελειώσει το σημερινό σεμινάριο θα συνειδητοποιήσουμε κάτι ακόμα. Ότι ως μηχανικοί έχουμε πάρα πολλή δουλειά να κάνουμε. Και πρέπει να βοηθήσουμε όλοι, και ατομικά και σε συλλογικό επίπεδο, να βρούμε τους τρόπους, ενώ τα χρήματα, τις διαδικασίες, τις νομοθεσίες κτλ. Για να κάνουμε αυτές τις δουλειές. Ευχαριστώ πολύ.
Καλημέρα και από τη δική μου πλευρά. Πολύ λίγα λόγια εισαγωγικά για τη σημερινή ημέρα. Ήδη ο κ. Πρέσβελος είπε τα περισσότερα. Προφανώς θέλουμε με όλη τη σειρά των σεμιναρίων και των workshops που κάναμε εδώ πέρα να καλύψουμε το τεράστιο κοινό που υπάρχει στον χώρο μας, στον χώρο της σύνθεσης, των αποτελεσμάτων έρευνας, εμπειρίας, μελετών που έχουν γίνει και έχουν κεφαλαιοποιηθεί σε κάποιες άλλες χώρες, έτσι ώστε να καλύψουμε την καθημερινότητα που αντιμετωπίζουμε στο τεχνικό κομμάτι. Υπάρχει βέβαια και το κομμάτι το διαχειριστικό της δημόσιας διοίκησης, αλλά ίσως μια άλλη φορά για αυτά τα πράγματα που άλλους πιο ειδικούς. Επομένως, αυτή η σημερινή μέρα, όπως είπε και ο κύριος Πρέσβελος, έρχεται να συμπληρώσει αυτά που έγιναν πριν λίγους μήνες από δύο συναδέλφους για 6 μέρες επί 8 ώρες την ημέρα, όπου αρκετοί συνάδελφοι μπορέσανε και μελετήσανε όλα αυτά τα θέματα που αφορούν τους ισόπεδους κόμβους αφενός και τους κυκλικούς αφετέρου. Και αν τα διέλθει κανείς, το πέρασα πολύ γρήγορα, υπάρχει ο κατάλογος, θα δει κανείς ότι στην ουσία ξεκινήσαμε από το Α για να καταλήξουμε στο Ω, και κυκλοφοριακά και από την ασφάλεια και από τον γεωμετρικό σχεδιασμό. Υπήρχαν κάποιες ειδικές μορφολογικές, θα λέγαμε, ιδιαιτερότητες που επέβαλαν και την άποψη της Ευρώπης. Και σήμερα λοιπόν βρισκόμαστε εδώ για να καλύψουμε αυτό το κενό. Έχουμε την τιμή να φιλοξενούμε αξιόλογους συναδέλφους οι οποίοι θα καλύψουν αυτά τα θέματα. Βλέπετε εδώ πέρα καταρχάς τον καθηγητή τον κύριο Πυλών, καθώς επίσης και τον κύριο Λίπορτ από την Βρέστη. Η θεματολογία που βλέπετε υπάρχει επίσης και στο πρόγραμμα. Και θα καταλήξουμε με τον συνάδελφο τον κύριο Σμάρτ από τη Μεγάλη Βρετανία και τον κύριο Μπρανόλτε και τον κύριο Γκρίσπλαχ από το Πανεπιστήμιο της Βαϊμάρης. Υπάρχει το υλικό της εκδήλωσης στο CD που έχετε πάρει, εκτός από, αν θα το πάρετε θα το πάρετε σήμερα, μία μόνη τελευταία του κυρίου Λίπολτ θα την αναρτήσουμε στο δίκτυο, επειδή δεν προλάβουμε να την βάλουμε στο CD και θα μπορέσετε να την κατεβάσετε από Τρίτη, φαντάζομαι, από την ιστοσελίδα του συλλόγου μας. Επομένως, ευχαριστούμε για την σημερινή σας παρουσία. Φαντάζομαι ότι δεν θα χάσετε το πρωινό σας και από τη Δευτέρα, επομένως να έχετε κάτι στο μυαλό σας από αυτά που θα ακούσετε για να αντιμετωπίσετε όπου χρειαστεί κάποια από τα προβλήματα που θα αφιχθούν στη σημερινή ημέρα. Και μπορούμε να αρχίσουμε τις ομιλίες μας. Ο πρώτος που θα μιλήσει θα είναι ο κύριος Λίπολτ, ο οποίος θα μας αναφέρει τα θέματα των ισόπεδων κόμβων όπως διαμορφώνονται πλέον κάτω από ένα πολύ καινούριο πρίσμα με βάση τους καινούριους κανονισμούς που έχουν αρχίσει να μπουν στη Γερμανία και φαίνεται ότι καταλήγουν, δεν χρειάζεται να σας πω πολύ περισσότερα. Υπήρξε μια μεγάλη συζήτηση για το τι, το πώς, δεν ήταν όλα τα πράγματα πολύ απλά. Έχει κρατήσει αρκετά χρόνια αυτή η συζήτηση. Σε αυτή τη φάση είμαστε στο σημείο να μπορεί κανείς να πει κάποια καινούργια πράγματα για αυτά τα οποία έχει καταλήξει η εμπειρία και η έρευνα στη χώρα αυτή. Και επειδή συνήθως στην Ελλάδα χρησιμοποιούμε ευρύτατα τους γερμανικούς κανόνες, ιδιαίτερα στους κόμβους, έχει σημασία να καταλάβουμε το πνεύμα.
Dear Mr. Sanrianos, ladies and gentlemen, thank you very much for your invitation. It's the first day for me here in your wonderful town, Athens. At the beginning, please excuse me my simple English. I have learned the Russian language during my school time in the former German Democratic Republic. But I believe, and I'm sure, you would not understand a presentation in Russian. I will try to speak a little bit slowly, then it's more easy to translate the presentation. I have to speak about current developments of road junctions in our new guidelines for rural roads. But I think in the first part of my presentation it's necessary to explain the generally new aspects in our new guidelines. It's a draft of the new guidelines, but the draft is finished at the moment and we discuss it with further ministry and we hope we can print these guidelines in the next year. The main problem in Germany in the accident overview is that we have the largest part of accidents inside of urban areas, but the largest part of accidents with fatalities we have outside of urban areas and not so much on the highways or interstates, not so much on the German Autobahn. In the most cases we have accidents with fatalities on the normally rural road, round about 72%. And if we see the accidents on the rural roads, then 50% of the accidents with fatalities are driving accidents. This means a car is too fast in a curve and the driver makes the accident alone. If we want to reduce this part of the accidents, then we have to reduce the speeds on the rural roads. The next large number of accidents are the overtaking accidents. And if we want to reduce these accidents, then it's necessary that we have in the future more overtaking lanes. And on the third place, there we have the accidents in the junctions. These are turning accidents or crossing accidents, and if we want to reduce these accidents, then we need less conflict points in the junctions. And not so much is the number of the pedestrians or cyclists and other accidents, and if we want to reduce this part, then we have to protect cyclists or the pedestrians, it's clear. In our new guidelines, we have created new road types. I will explain it now. And we had also the task to have new rules for roads, for the new construction, and also for the reconstruction of existing roads. It's the main part in the future because of our road network in the main part is finished now, and we have not so much roads to new construct. And the third important point was the evaluation of the traffic safety. You will hear today also a presentation about the road safety audit. And these aspects were also integrated in our new guidelines. If you see the road network classification in Germany, then we have two category groups for roads outside of urban areas. These are the interstates or motorways, the German Autobahn. This is an own category group, the normally rural roads and the roads inside of urban areas. For these three groups we have own guidelines, new guidelines. The guidelines for the interstates are finished 3 years ago. And I have heard from Mr. Psarianos, you have also planned and designed interstates in Greek with these German guidelines. It's a nice aspect for us. And I will speak about the green marking areas. These are the rural roads. And for this rural roads we have connection functions. We have rural roads for a long distance until shorter and shorter to the short distance roads. Yes, a generally question at the beginning what should we do with the design speed and with the operation speed in the future. The design speed estimates in Germany at the moment only the design curve radius and in a relation the closed parameter. And more the design elements are estimates by the 85% speed, for example the summits or the super elevation rate or the stopping side distance, but it's difficult more and more. Why? For example the speed summits are too high. Yes, we have a speed limit on a rural road of 100 km/h, but the 85% speed on a new constructed road is around about 110, 115 km/h, and we can't use this size, this speed to design elements. We can't design a road for a higher speed like the speed limit. It's very difficult. And both speeds together does not estimate, for example, other elements, cross-section or type of intersection, or also the road operation level. That's why we have decided in the future not use a design speed. We have a speed to estimate the design elements, it's clear, but it's not the generally value. We have created a new group or a new basic, design basic, and this are in the future the design classes. The design classes estimate now the cross-section, the road operation level. For example, it's only an expressway, only for the fast cars. It's normally rural roads, also for cyclists or pedestrians or for agricultural vehicles. The design classes estimate also the type of the intersection or the junction in one level or in two levels. The road operation in the junction, it's in junction with traffic lights or without traffic lights, only with traffic signs, or it's like inside of urbans, the right car is the first car. And the design classes estimate also the design elements in the relation with simple design speed. In other countries, they discuss this development as self-explaining roads. We say in Germany these are standardized and recognizable roads. The driver can recognize the type of the design class, the type of the road, and the differences between the different types. I will show you the examples. You remember, I spoke about the connection functions. Long distance roads, over-regional, regional, or short distance. For every of these connection functions, we have an own design class. It's a very simple relation. The long distance road, this is a design class 1, over-regional is a design class 2, and so on. This is a normally case. Sometimes we have too much traffic or not so much traffic on the design classes or on the road category and on the connection functions. That's why it's also possible to have an upgrade or a downgrade. If you have a low traffic volume, you can make a downgrade, but then you must use all elements of the other design class. Not only a small cross-section, not only a simple road junction. It's necessary to use all elements. And if you have a very high traffic volume, then it's also possible to make a downgrade and to use a better design class. Sometimes, not so often, it's necessary. So, and we have different principles in these design classes. For example, as one of the most important principles is the passing on the roads, so overtaking. In the design class 1, we want to have every time continuous alternating passing lanes. All overtaking lanes, this is the cross sections 2+1, it's in the last 15 years well-known cross sections. In the design class 2, we want to have single passing or single overtaking lanes. In the design class 3, we have not regular passing side distances. It's too expensive to design a road with very large passing overtaking side distance, and the traffic volume is in the most cases too high to overtake very safe. And in the design class 4, these are very small roads, small cross sections and short distances. It's overtaking not necessary. And in the consequence, we have here the regular cross section types. It's the cross sections 2+1. It's a similar cross section, but only with short lanes, bone lanes for the overtaking. And you can see also a difference in the marking line. Here's, for example, a collar, and the marking lines are widther, like here in the design class 2. And these are the sections without overtaking lanes. And it would be good, very good, if the overtaking would be forbidden, but it's a difficult process, also in Germany. In the design class 3, simple rural road cross-section, and in the design class 4, it's a new cross-section type, like the cross-sections in the Netherlands, for example. We have seen the road network there, and we want to use also in Germany this cross-section. It's a smaller cross-section without a marking line in the middle of the road surface. So, in relation to these cross sections, we want to have traffic mode on the road also different and depends on from the design class. And for the design class 1, only for fast vehicles, without agricultural vehicles, without pedestrians, without cyclists. In the design class 2, also for the slower vehicles, but not for the cyclists. In the design class 3, in the most cases, it's better for the road safety. It's clear to have an own way for the cyclists. You have to check it. And the design class 4 is free for all types or all kinds of the traffic. And it would be very nice if we had a speed limit on this road, but you have on this slide, there we have traffic signs 110, 100, 90 and 70 kilometers per hour. You can't see it, it's a mistake in the presentation, I don't know why, but it's not so important because of it's not possible to have a speed limit in this difference in Germany. That's why we advance to design the road for this speeds. The design class 1 for 110 kilometers, design class 2 for 100, 3 for 90 and 4 for 70 kilometers per hour. The alignment, it's clear in the design class 1 we have very large design elements, alignment for high speeds, and until to the design class 4 the elements are smaller and smaller step by step. And last, we have also a difference in the traffic guidance in the junctions. In the design class 1, we want to have only exits and entries, like on an interstate, crossing in 2 levels, and only like on the German Autobahn, braking lane and acceleration lane, and entry and an exit and an entry. In the design class 2, we want to have only turn off and turn on, not crossing. And it would be better for the road safety if you have traffic lights on every junctions. Not only if it's necessary, if you have a high traffic volume, in every case it would be very good. But this is also a difficult process in Germany. In the design class 3 we have crossing, turn on, turn off, or the roundabouts. And in the design class 4 there is a very low traffic volume. There is a roundabout not necessary because of the traffic volume. It's too low. And that's why there's enough if you have very simple junctions or T-junctions. We have different basic forms of road junctions in our new guidelines. In the past we had this 4 types. We speak about the level T-junctions or crossing on single carriageways or 2-lane roads. We speak about the roundabouts, and we speak about the grade separated interchanges, and this is a middle between the grade separated and the normally junctions. It's a half part grade separated. It's a crossing in 2 levels, but there are in both roads normally T-junctions. We can combine these types of junctions with the operation, with traffic lights or with traffic signs, stop, main roads or waiting. And we want to have traffic lights not only for the main traffic, also for the left turning, an own light or an own signal. And we can also combine, if we have crossing of 2 design classes, then we have a combination between the junctions, and here you can see, for example, if two roads in the design class 1 are crossing, then we have full cloverleaf, for example. It's clear, but this is very seldom, only if we have a very, very high traffic volume. If you have the crossing or the connection of a design class 1 and a design class 2, then you can see it's like an exit and an entrance with traffic lights. If we have a connection between 1 and 3, then we can in the second road use roundabouts or normally simple T-junctions, and the traffic light for the road safety is to check. And the connection between 1 and 4, it's not available, it's not allowed. And so on, step by step, you can see the different combinations, and you have this figure also on your CD-ROM, and you can look also at home all these combinations. And at last, if you have design class 4 with design class 4, the combination, then we have a very simple junction. So, in summary, I want to introduce these 4 types. The type or the design class 1 is a type only for fast vehicles with very large design elements in a cross section 2+1 and with junctions only with entries and with exits. And an example we have discussed in the last year how we can create the marking line that it's recognizable. It's possible to use such form, but this is a little bit less. The bishop caps in the middle of the figure, it's a problem for the winter operation servers. If you have snow and you must clean the road surface, then you will destroy, or the road operation service will destroy these bishop caps. And we discuss also a color in this marking line. Color is also not so easy. Yellow we have in the working zones on interstates. Red, these are the lanes for the cyclists in Germany. And so we have a very modern traffic orange, but in the construction period of this road we have seen also a cyclist in the middle of this road, and the road authorities mean it's too dangerous, and that's why we have also some new roads with this green, and at the moment we check what is the best practice for this cross section, what is the cheapest, what is very long to see, what for color has a good quality, and so on. The design class 2, this is a road for 100 kilometers per hour with T-junctions, with turning on and turning off, and with single overtaking lanes. It's a good method to improve the road safety on existing roads. On an existing rural road, it's very difficult to create or to reconstruct a cross-section with a 2+1 cross-section. Because of you have not enough place, you have to protect the environmental, it's difficult to create the junctions, but it's possible to create sometimes, if you have enough place, such a single overtaking lane. Here are some examples from German test roads, and here is also the marking in the middle a little bit easier, but we want to have a higher density of these white lines for the future. It's not enough here in this example. This were the first tests in Germany. The design class 3, it's a normally road with a junction, simple junction, or with a roundabout, and if you have a junction you have to check a traffic light. We would like to have a speed behavior of 90 kilometers per hour. At the moment it's not impossible. At the moment we have 100 kilometers per hour. It's our task for the future in Germany, and everybody of you knows such a simple rural road. I must not explain this cross-section. And the last, this is a design class 4, and the design class 4 is a very small cross-section, only 5 meters, and with these marking lines we want to reduce the road surface for the drivers. The single drivers have to drive in the middle of the road, and only if another car is oncoming you can drive near to the hard shoulder. But with this line we want also protect the hard shoulder, that not so much cars are driving here in this area. And we have also tested such cross-sections. We hoped that the drivers drive very slowly, but it isn't it. In the Netherlands they drive very slowly, 60 kilometers per hour or 70 kilometers per hour, but there is also in combination a speed limit for these areas. We have not a speed limit, and we have reduced the speeds on this road from 105 kilometers per hour to 103 kilometers per hour. There's nothing different. So I believe at the moment the first part is over, we make a break, and Mr. Brilon will continue, and in the second part I will show you some details from the chapter for the junctions. Thank you very much.
Οι ερωτήσεις θα γίνουν μετά πέρας των 4 ομιλιών του πρώτου μέρους. Στη συνέχεια έχουμε τον κύριο Βιλιόν, ο οποίος τουλάχιστον για τους οποίοι ασχολούνται πολύ με τα κυκλοφοριακά θα γνωρίζουν ότι και στο καινούριο highway τα πάστημάνια που εκδίδεται εντός των ημερών στην Αμερική, καθώς επίσης και στο αντίστοιχο που βγήκε επίσης πρόσφατα στη Γερμανία. Ο κ. Βιλιόν είναι τους βασικούς συγγραφείς αυτού του βιβλίου και στην Αμερική και στην Γερμανία. Επομένως, έχει να μας πει πολλά χρήσιμα πράγματα και σε αυτόν τον τομέα και θα ρίξει πολύ βάρος στο κυκλοφοριακό κομμάτι. Η πρώτη εισήγηση ήταν για τους κυκλικούς κόμβους και την εμπειρία που υπάρχει στην Γερμανία.
Good morning, ladies and gentlemen. It's interesting to speak in such a beautiful auditorium, and my task is to talk about roundabouts. So our topic is this, a roundabout. Before I start into details, let me give you short information about history. People say that the first roundabout in the world was the Columbus Circle in New York, and it has been installed in 1905. And it has been initiated by a guy, his name was William Plebs Eno, and he was not a traffic engineer, he was something like a playboy. He was a rich man, and his hobby was traffic engineering. And the Columbus Circle still is a roundabout. It's on the corner of the Central Park in New York, and you can see it in the present condition on this slide. The first roundabout in Europe was the Place Étoile in Paris, and it's now called Place Charles de Gaulle, and you know it from some touristic activities. It's a huge place with 12 approaching streets, And in our times, we shouldn't say it's a roundabout. In our times, it's a very specific individual thing. It has traffic lights on the entries, and on the circle itself, it's the old rule right before left, which is a very strange experience if you would drive there in the afternoon on such a big installation, driving with right before left. So it's not a roundabout. And the roundabouts have been introduced to Britain, as far as I know, also by this guy, William Phelps Eno, in 1924. And what I read in an article is, I should say it carefully because a British colleague is here, that this word roundabout was just a joke by journalists. They didn't understand what it was, and they said, it's terrible, it's so roundabout. And this joking expression now is the technical term for this type of installation. I don't know which was the first roundabout in Germany and also not in Greece. In recent years, in the last 20 years, there was a big movement on the European continent to introduce modern roundabouts, and modern roundabouts are small, not as big as this one here. And in the United States, sometimes, for a long time, they did not understand what it was and they didn't like it. But in the last 5 or 8 years, they discovered that roundabouts are interesting. And now they are also introducing roundabouts, but in America everything must be big. So also the American modern roundabouts are big, and there is not a big difference to what they call the old rotaries. Also their modern roundabouts are rather similar. And just recently there has been published a book, Roundabout Guide, which is very nice, very good, nice book, but it's a different style of roundabout than what we have on the European continent. And what can we learn from these comparisons? I think we can learn that each nation finds its own culture of roundabouts. Roundabouts seem to be very closely related to the culture of a country and to the traditions of general behavior, of driving behavior, but it's also, of course, influenced by traffic rules to some extent. And so my impression is that each country must find its own culture of roundabouts, and so the experience from other countries could help as an example. And so one of these examples may be the German experience. We have traditional roundabouts in Germany, which are big ones. This is in Münster, in the northern part of Germany, and it carries around 45,000 vehicles per day. You see there are also cyclists on the roundabout, which is very strange, but very dangerous, of course. And so this is another example in Munich, not so much traffic, but there is a tram on this roundabout. And one experience in Görlitz, which is close to the Polish border, and also a very old one. Nobody knows when they have been, or I don't know, when these have been introduced. Regarding the history of traffic rules, in Germany, roundabouts were first mentioned in 1953. There have been roundabouts before, but I don't know how the traffic rules were at those times. Since '53, the rule in Germany was traffic has priority, and this was only indicated by this one sign. In England, they have the offside priority rule, which means priority for traffic in the circle, but in addition to that, on the circle, priority for vehicles on the inner lanes. And this, from my understanding, is a secret why roundabouts in Britain are so successful with very high traffic volumes, as we will see later. In the Vienna Convention from 1968, which created unified regulations for traffic rules and signs in Europe, there was the regulation that this sign here, this sign should not longer indicate priorities, as it has been the case in Germany. So in Germany, this sign was taken away and it has been replaced by conventional signs. But this regulation, as you see it here on the bottom, sorry, the mouse is not working very well. And this sign, meanwhile, has this combination is applicable with the Vienna Convention, and it is used in many countries in Central Europe now. So what about the German rules? We have, let me say, 4 types of roundabouts, the minis, the single-lane roundabouts, then 2-lane roundabouts, but very compact. We do not longer allow the big 2-lane roundabouts, and we have signalized roundabouts. And this figure shows us where these different types are applied, depending on the diameter, on the ADT. And it's easy to read this picture. And we will now discuss these different types. And again, let me say the large 2-lane roundabouts are not longer state-of-the-art. Generally, roundabouts produce benefits for motor vehicle drivers. They produce lower delays than traffic lights, if they are applicable. And they produce higher safety for motor vehicles. Also for pedestrians, no delays and higher safety. The problems are for cyclists. Cyclists have a higher risk on roundabouts, as we will see later also. Everything for Germany is written down in a guideline from 2006, which has been published by the FGSV. So the big ones are not longer state-of-the-art. Let me first talk about the mini roundabouts. Mini roundabouts have been invented in Britain by Frank Blackmore, and what I know is that the first installation was in 1968. In Britain they make roundabouts just with paint on the middle of the road, and we found out by some experiments that this is not sufficient for Germany. And so we defined a mini roundabout as an intersection with a central island, but the island can be overridden by big vehicles like buses or trucks. The passenger cars are forced to turn around this island, and they are forced by traffic rules. This central island should have at least a curve of 4 centimeters. We found out if it's much below 4 centimeters, then many passenger car drivers ride over this central island. And recently there was something in the internet which seems to be a joke, where all the drivers went straight ahead, and but without an island. So this central island is important. The capacity is unexpectedly large. It's 20,000 vehicles per day. They are very safe and they are working quite well, but we only do use them in urban areas. From these first experiments, let me show you the right figure. This is the accident cost rate, and 20 intersections, which most of them had normal T-junctions or cross-junctions without traffic lights. One had a traffic light, and overall the accident cost rate went down from nearly 10 to less than 4. And I think this was a big success. And now, after this success, they have been introduced in the traffic rules, and they are now standard installations within cities. They can be built by very low costs, just a little bit paint and an asphalt thing, island in the middle, but so that can be very cheap. There were some experiments with rural mini roundabouts, but they were not successful, and this is not longer recommended. So here we see pictures of these mini roundabouts. Here is another picture of a mini roundabout. The width of the circulating roadway is always around 4.5 or 5 meters. So the width of the central island is just depending on the space which is available. And there is a rule, if there is space enough, then a mini roundabout should be avoided, then a normal roundabout should be built. So let's talk about this normal one-lane roundabout. And here we see some examples. Here are the characteristic design elements. They can be built urban and on rural roads. Diameter minimum is 26 meters, which makes it possible that a big truck can turn around the island. But 30 meters is a better minimum figure. The circle width depends on the radius. The smaller radius needs a big circle width. So 30 meters gives a good solution for urban conditions. The maximum should be 45 meters, but of course there is no upper limit. It could also be 100 meters, but this doesn't give any sense. Very important is that the crossfall of the circle is to the outside, and the standard value is 2.5%. If there is a very small urban roundabout, let me say 26 meters, then this 8-meter wide roadway would produce a lot of asphalt. And this would give also the possibility to the drivers to go through the roundabout very fast. So on these small ones, we introduce this central apron with a curb height of 3 or 4 centimeters. But this should only be made in urban areas because it's difficult to make a construction which is permanent. This construction of the central apron is very critical. We only allow single-lane entries and exits, no flaring of entries, and the entries should be as perpendicular as possible. And we have some rules about the turning radii, which are very narrow, to force drivers down to lower speeds. These single-lane roundabouts could cope with a traffic of a maximum of 25,000 vehicles per day. Here are some design elements, the central apron, which I mentioned. Here we see another figure with this central apron. And we found out that these single-lane roundabouts seem to be the safest type of intersection whichever you can make. Some figures for safety. We should not concentrate on the on the large columns. Let's look on this very small column of killed people. And you see these in before and after studies with a couple of hundred roundabouts. These studies found out that there is a reduction of nearly 90% of the number of severe injuries and killed persons by converting an intersection into a roundabout. This is another figure from a lot of roundabouts in Bavaria. You see on the left side signalized intersection, on the right side roundabouts, and you see these columns are much lower for roundabouts. How to treat pedestrians? Pedestrians usually should go on a zebra crossing. Zebra crossing in Germany means absolute right of way for pedestrians, and which is observed by the drivers. And you see some examples for that. But without any risk, you could also operate a roundabout without zebra crossings. The pedestrians get the same right of way. Drivers behave in such a way that they allow the pedestrians to cross without any delay, also without a zebra crossing. The critical point are the bicycle drivers, and bicycle drivers carry the highest risk on roundabouts. And it's very safe to guide them through the roundabout, but of course with a lot of traffic, much more than 15,000, it's could become a little bit critical. So we have a rule, above 15,000 we should have separate bicycle tracks, but below this, also if there is a bicycle track on the road connection, for the roundabout, the bicycles are guided on the to the normal traffic and go through the roundabout within the normal traffic, because the passenger cars and the bicycles go with the same speed and they don't need to overtake on the roundabout, and this is the safest solution. Which is extremely unsafe are bicycle tracks on the roundabout. whoever makes this makes a severe mistake. This is extremely dangerous for cyclists. What happens are accidents at the exits and on the entries because the cyclists are forced to drive to ride on the most dangerous part of this roundabout. Without the cycle track, they would go in the middle of the roadway, and this is the safest way to cycle. So these separate bicycle tracks are a good solution. They should have a distance from the circle of at least 5 meters. That's very important for safety. Initially, there were experiments where the cycle tracks were just on the edge of the roundabout, and this, like these figures show, and this turned out to be very dangerous. So the figure on the right side is correct, 5 meters distance to the roundabout. Or let me show you, this figure was 4 meters. On rural roads, we don't allow priority for cyclists, so cyclists should get the sign, the yield sign. That means they should take care of their own safety. On the left side, you see an urban installation where the cars have to observe the priority of the cyclists. On the right side, for an urban place where the cyclists do not have priority. For design, the most critical part for design are the exits, because the big trucks would run over the curbs and destroy everything which is there. So it's important to make the exits and of course also the entries fit for the big trucks, and the swept cars must be taken into account very carefully. One solution might be direct right turning lanes, which we call bypass. You see here another example of such an extreme example of bypass. I don't like this, but it could help. And for the bypasses, it's important to have accelerations lanes where they come into the new road, and not these direct entrances, because these direct entrances are also very dangerous. So short accelerations lane which enable the driver to put his car parallel to the priority traffic. Some short ideas about two-lane compact roundabouts. Here are 2 examples. Compact means we have a wider lane. We also allow, if necessary, 2-lane entries, but the circulating lane does not allow trucks to run around the circle side by side. And we do only allow them with few pedestrians and cyclists, if possible no pedestrians and cyclists. So they are mainly for urban or for rural roads or peripheral roads. The circular circle should have a width of 8 to 10 meters, no lane markings on the circle, diameter between 40 and 60 meters, no cyclists admitted to the circle. We do only allow single lane exits. 2-lane exits turned out to be dangerous. And 2-lane entries were required. Short mentioning of the capacity. This is an equation by which we calculate capacity. I think it's, I've just put it into the presentation to make it possible for you to understand the equations if you look on the printed version. So what comes out is this diagram, and that means for a mini roundabout we have the lower curve, which we did not calibrate by German experience. It's just based on British experience. And for a single lane roundabout we can use this curve for a narrow one with 26 meters. For a 2-lane roundabout or semi-2-lane roundabout, we have this equation. For a wider one, this one, and for the big old ones we have this kind of equation, but of course this type is no longer recommended. The 2-lane roundabouts do not create much more capacity than the single lanes have, and the reason is that the German drivers do not accept the left entry lane. And so these are figures, the lower line, the maximum which can be expected by the different types of roundabouts. With signals we can come up to 50,000, but I don't want to talk too much about signals. We have a program which can calculate these things. Also simulation would be a solution for estimating the performance and the capacity of roundabout. Some words about safety. This is taken from a paper which has been produced by a guy who was not in favor of roundabout. He was not an advocate of roundabouts, but he found out by his institute that compact roundabouts seem to be the safest solution. But compact roundabouts are only safe if the central island is free of dangerous obstacles. You see here a figure or a photo from an accident, severe accident with a couple of killed people. And the driver has lost control of his car and he collided with this monument. And so these monuments should be completely forbidden on the central island of a roundabout. Roundabouts can also be combined with trams, but only by the help of traffic signals. Roundabouts should always be circular, no dangerous obstacles. Design is important for the acceptance of roundabouts in the public, so beautiful design would be would increase the acceptance of roundabouts in the population. Some curiosities: we have one roundabout in Germany where there is a petrol station on the central island, which I think is not a good solution, but it's curiosity. Or a curiosity could also be such a loop. And what I cannot talk about too much is roundabouts cause less fuel consumption and emissions. Roundabouts reduce the noise emissions. Roundabouts usually are cheaper to operate than traffic signals, and roundabouts are highly appreciated by citizens and politicians. You can read the conclusions, but I have overrun my time, so thank you for your attention.
Θα συνεχίσουμε τώρα με το δεύτερο μέρος του κυρίου Λίμπολ, ο οποίος είναι αυτή τη στιγμή και ο πρόεδρος της Ευρωπαϊκής για το πρόσφατο.
Mr. Brüder spoke about the creating of the island in the roundabout, and we have in the near of Dresden, in the entrance to the mountains, Saxony, Switzerland. It's sandstone mountains, not so high. We have a roundabout with sandstones in the island, with a height of roundabout of 4 meters, for example. And on the top of the stones there is a book for the people who are going on the top of the stones in the middle of the island. Die Bergsteiger, ich weiß nicht, was das auf Englisch heißt. Mountain climbers, yeah. Yes. So, in the second part I want to introduce some details from the chapter of for the junctions in our new guidelines, and I want to speak about the basic demands for the planning of junctions, and I want to explain a little bit the basic forms or types and the combinations, and I want to show you also some design examples and some details. It's not the full chapter, it's clear, it's too long, but you have the slides on the presentation on your CD. This figure I have shown you in the first part. It's an old figure of our old guidelines, and in the future we differ a little bit other. We have the graded separated interchanges, and we say in Germany planfrei. It means in English like free in the levels. And the next is normally exit and entrance on a highway or on an interstate. It's graded separated interchanges. It's a part of free of the level. And here we have the exit and entrance, and here we have an only T-junction. And this mix of a simple junction and of this grade separated interchanges, we have mu created in half part grade separated interchange. The simple level T junction or level simple junction and the roundabout. And these are the finally figures in our new guidelines for the combination of the different design classes. And here we have only junctions in this figure, from the clover leaf about the over the roundabout until the simple junction. And some combinations are not available, not allowed, or not recommended. For example, a combination from equal 2 and equal 4. And sometimes we have a picture or pictogram for the traffic light with an own signal for the left turning traffic, and sometimes we have a figure that it's better to check this traffic light. But in these cases, it's every time a hard discussion with the traffic authorities in Germany. It's a special situation. We have the road authorities who planned and designed the road, and the traffic authorities, these are in the most cases not engineers, these are jurists. They have to decide the traffic signs and the marking lines. And very often these are in Germany hard discussions. And in this figure you have all the combinations for the T-junctions. It's similar like the junctions. Here we have the trumpet type or single T-junction with traffic light, without traffic light, or with a roundabout. And also in these cases some combinations are not recommended or not available. In a comparison of the road safety level between different junction types, we have the experience that the normally simple junction has the highest level in the unsafety, and the same level has a junction with traffic lights. Only if you have in addition a second traffic light, and that's why I spoke so often about this point, if you have a second traffic light only for the left turning traffic, then you can reduce the level of the unsafety very good, and you have a very higher safety level as the same level like a half grade separated junction. If you have a junction like an entrance and an exit on an interstate, you have a very good level of the road safety, and you have the same level on a normally road junctions if you are using a speed camera. For the road safety, it would be very good if you have on all junctions a speed camera. But nobody likes speed cameras, also in Germany not, and that's why is this solution not possible. And the best level we have heard it from Mr. Pilon as roundabouts. But from this figure we have decided the combinations for our design classes. So we have, of course, the figures for the examples. It's to see, yes, it's very good to see. Here, for example, a half part graded separated interchange. This is a bridge for the two levels. Here is a very large T-junction, and here is a roundabout, and here is, are the figures for the other cases for a T-junction with a high level and with a little bit easier level, or a little bit simply. And We have also the figures in our guidelines for the position of the slip road depends on the main turning traffic volume. And for all cases in the practice we have such figures. We have also in our guidelines some generally aspects for the roundabouts, some new aspects, for example here a figure with a bypass for the geometric designs, but most of the details are in the own guidelines for roundabouts. You have seen it in the presentation from Mr. Brilon. This is a special situation in Germany because of the guidelines for the roundabouts have also a long tradition, and it's so much that we didn't want to integrate all the aspects. These are also different working groups, different technical qualities in our national research boards, and so on. And that's why it's this part in our guidelines a little bit short. So, if we see normally T-junctions, then we have the area for the left turning traffic, and you can create different cases. We have different types. For example, type 1, it's design standard on a high level with an opening area, with a braking distance and a waiting distance, and these types are a little bit simpler and they have not such a high level in the design standard, and this is a very simple case in the type 3 here without an own left turning lane. When you have to use the different types, there we have some using criteria. The main first road, here we have the design class here on this side. We have the operation mode with traffic lights or without traffic lights. The second road, we have here the design classes, so you can decide your combination in your case in the practice, and so you can see how large is the length, for example, of the braking distance or the length of the waiting distance. There is a value in meter, or it depends on the traffic volume, and you must estimate it with the German highway capacity manual. And in combination to the left turning types, you have here, and from this depends on the left turning type to use it. So the right turning area, you have also different types, and this right turning types you must for this right turning types you must also consider the kind or the design standard of the access type here in this case. You can see different types with an own lane for the right turning and a small triangle island, and here is the most simply design standard in these cases. There are a lot of different right turning types, more like on the left turning types, and here also you have as a relation to the design class from 2 until 4 with traffic lights or without traffic lights, right turning lane after the German highway capacity manual, and you have to consider the separate pedestrians and cyclists, how they are crossing in the main road, or they are crossing the main road, and then you can choose your right turning type here on this side. And last, the access type for the second road here, you have different types with 3 lanes for right turning, left turning, and with straight on in the junctions. or only left turning with an own traffic light. And here, this case is in a T-junction. And these are very simple cases with traffic light or only with a traffic sign. Some details for the planning of junction. You have to consider the angle for the crossing of both roads. Here is the angle very small. You have very bad visibility situations, and that's why you have two kinds to improve the situation. You can design the alignment, and there you have an angle of 90 degrees, or you can make two single T-junctions and connect these both T-junctions. These are some figures for the... Ach, jetzt komme ich nicht drauf für die Jungs mal. Longitudinal weight. Here we have a sec and a summit and a sec, and you have no difference in the angles. Here there are some differences in the angles from the crossing roads and from the main road, and here the combination, and in these figures are the load values for the different cases. You have to control the side distances in the junctions. For example, here is not good or the wrong directional island. If the driver is oncoming, he can't see the directional island. He has a view or the eye tracking in the other lane. It's better that the directional island is so large that the eye tracking can see the end of the directional island, and so see the design of the T-junctions. Also is to consider the stopping side distance. We have some new figures created in our guidelines. The stopping side distance is this value on the directional island here, and this is the area is you must see that this area is free of planting, that the driver can see this traffic sign of the T-junction. So, some examples for the directional islands. We have large directional islands here in this case, and we differ in the guidance without cyclists on the left-hand side, and in the cases with cyclists, and in this case the cyclists have to cross the directional island here on the top of the island in the pro-colored area. And with the small directional islands for the lower design classes have this design standard, and the cyclists have to cross roundabout in the middle of the directional island, that they have enough place to stand with their bicycle here in the middle of the island. So, I believe I'm finished, and I hope we have a little bit better, or we are a little bit better in the time after your timetable. Thank you very much.
Ευρώπη, επειδή είναι ένα θέμα προβληματισμού, στην Ελλάδα βέβαια είναι εντελώς άγνωστη, αλλά θα δούμε και τις ιδιαιτερότητές τους και τα πλεονεκτήματά τους, και επομένως είναι χρήσιμο να μάθει κανείς πότε και από ποιες προϋποθέσεις μπορούν να χρησιμοποιηθούν, και για όλα αυτά να μας μιλήσει ο πολυειδικός ο κ.
So now I have to talk to you about turbo roundabouts. Turbo roundabout is not state of the art in Germany, it's more like an experiment still. There is some experience with that in Germany, but there is more experience in the Netherlands, so I'd like to talk about both aspects. What is a turbo roundabout? A turbo roundabout is a roundabout with a variable number of lanes on the circle, and it should be constructed in a way that lane changes within the roundabout are completely avoided. So no lane changes on the circle. And if we figure this out more detailed, then we find we have a chance to define 4 types of entries to such a turbo roundabout. And the typical one is the upper one, which I called in one. This is a turbo entry, which you see also on the right side on the picture. All the other types of entries are conventional, like on conventional roundabouts. Such a turbo roundabout could also have a 2-lane exit. And this 2-lane exit is constructed in a way that the right lane is forced to exit, whereas the left lane can be used, or the driver who is approaching on the inner lane of the roundabout can continue on the circle, or he can exit at this turbo exit. All the other types of exits are conventional except the lane reduction, but this is also easy to understand. So it's typical that a driver should not change lanes within the circle only if he would like to turn around, go back into the same direction where he came from. This is not encouraged, and this usually should not take place, but it's possible. So you on the left side you see a solution from Netherlands, on the right side a solution from Germany. And this is a guy who has invented this. Bertus Fortuyn from Netherlands. He was an officer in the road administration of the province South Holland, which is the area north of Rotterdam. And on the left side you see one of the first turbo roundabouts, which is very close to the airport of Rotterdam. And the first one which they had built is this one. That was the place where they invented these turbo roundabouts. You see, it's a diamond interchange, and it has been signalized, but signalization was not sufficient for the traffic, and so they constructed this interesting thing. They separated the different lanes by very high curbs. That are not curbs, that are something like this height of concrete material. And of course then every lane must be able to be used by, or must be prepared to be used by the biggest truck. And this is still in operation. It's in the area between Rotterdam and Hoek van Holland. But later on they found this could also be transferred, this principle, to normal roundabouts. And you saw one already in the picture before. And what is typical for the Netherlands is they build curbs in the middle of the road. So the drivers, usually with a passenger car, it's difficult to cross this curb. And so the drivers have no chance to change lanes within the circle. They must follow these curved lanes. And these curbs are built in Netherlands very well, so they have a fundament and they are very strong constructions. Here you see another example with curbs also on the approaches, a curb on the circle. On the right side you see also a bypass. And this should be a typical one with 2 lanes on the street from left to right, and with single lanes each direction on the from top to the bottom. And when you are driving in such a roundabout, you are feeling like in a washing machine. You enter it and you know you come out somehow, but you don't know how. So just go ahead and you can be confident to get out, but you have, or I have the feeling when I drive such a roundabout, I have the feeling that I have no control of myself. I just can go forward. In their guidelines, they also have turbo roundabouts with 3 lanes. And for the preparation of this presentation, I asked a colleague via internet or email, do you really have these ones with 3 lanes on the circle? And he answered, no, there is no one in Netherlands. It's in our guidelines. We hope we will have one soon, so this also seems to be a little bit unrealistic. This is a movie, oh sorry, this is a movie, it's not a real case, it's an artificial animation, but this gives us an information how it would really work, such a modern turbo roundabout in the Netherlands with curbs on the central or on the road. So these curbs are of course a problem. They might become a problem for motorcyclists. If a motorcyclist would hit this curb, it might be his end. And in Netherlands, they do not have severe winters, as we have in Germany. And so in Germany we are afraid that winter service, snow removal might become a problem with these curbs. There is a guideline from Netherlands, which is very interesting. It's not very cheap. And here you have the information where you can buy it. Meanwhile, there seem to be something between 50 and 100 of these turbo roundabouts in the Netherlands, and there are coming more. So the characteristics are narrow curvature, curbs on the circle and on the approaches. In Germany, we would expect some problems if we would build curbs on the road. So we are not very happy with this solution, and there is a committee which is discussing this, but they have decided not to recommend it for guidelines. So what was the situation in Germany maybe 10 years ago? We do not have the possibility to build this large roundabout, but there was always a desire to build bigger roundabouts and hoping that they could cope with more traffic. And we have a restricted view on large roundabouts. We would like to have higher capacities, and there could also be the case that traffic is concentrated on specific movements. For instance, on movements from, in this case, to the left. And for this we have this bypass solution. If the big traffic is going through just straight ahead through the roundabout or through the intersection, what could we do then? And there was one example which is in the southwest of Germany, in the city of Baden-Baden. And this is a situation where you see already this roundabout. These were areas which have been occupied by the French army until a couple of years ago. So on the left side there were the French barracks, on the right side French housing areas, and it was like a French town in the middle of Germany. That was the headquarters of the French troops in Germany. But they disappeared after 1990. And what to do with these areas? And shopping center has been built on the left side, housing areas, modern housing areas are built on the right side, and they should get access to this motorway which is cutting through the middle of this area. And here you see the traffic demand, 31,000 vehicles per day, and only through traffic. What to do with that? And the first idea by the traffic engineering authorities was to build a grade-separated diamond interchange. But that was not desired. Architects urged for building a roundabout, and also the shopping center wanted to have not a grade-separated solution, because on the grade-separated solutions the drivers would just rush through. They should be forced to stop to see the shopping center and to decide to go there. And so this shopping center made it necessary to have a grade solution, and so at the end this roundabout was constructed, and I should say I have also invented it. I made this sketch for a solution, not knowing that the Netherlands had already invented it before. And so this has been built, and so you see 2-lane exits with a lane drop, and this is a sketch how it has been built. Very important is no cyclists, no pedestrians. They were forced to build a bridge to cross non-motorized traffic over this motorway. This is a solution how it has been built. You see the bridge in the background, and I have more slides here. And so you see these 2-lane entries with a lane addition in the circle. We have no curbs on the circle, no pedestrians. Here are other pictures, or another picture from an entry. This is a critical entry from the, these drivers are approaching on this motorway, and they are coming from a larger motorway, so they are adjusted to high speeds. And this is one of the exits. We have studied this roundabout very intensively by cameras, by accident analysis and so on. Some results from this study show us that most traffic is concentrated on the right lane. You see 76% on one entry, on the other side 61% of the traffic which is concentrated on the right lane. Also here the left lane is not accepted by the drivers so frequently. But more studies showed us that the use of the left lane is depending on the traffic volume, and I shouldn't say on the traffic volume, is on the, I should better explain it here. This is the reserve capacity, and that means this is the capacity, or this is capacity minus traffic demand. And if it's zero, that would mean we are there is no reserve capacity. The entry is full, maximum entry flow, and we see then there is a rather equal distribution of traffic on both lanes. So only if there is not much traffic, then the left lane is undersaturated tremendously, and most of the traffic is on the right lane. What about the acceptance of these lane markings, which we just used instead of the Dutch curbs? And you see drivers sometimes are crossing the lane markings. And here we see an accident. I could also have shown it as a movie, but you see this driver has chosen the wrong lane. He tries to go over. He doesn't see the other drivers, and they collide. And after a short stop, they continued their trip, so it was not reported to the police. From the accident records, we found this doesn't happen very frequently. We found only one accident of this type which was recorded by the police. So this seems not to be a real risk. What else could happen with road markings? You see a driver could cut over here, he could cut over this one, he could come from the right lane and try to exit, that was, to continue on the circle, that was this exit which we saw just before, or a driver could just go through on the straightest lane. Here you can study it in detail on the printed version if you print it from the CD, and this was the case which we were afraid of, and which should be avoided by the Netherlands curbs. And you see the percentage of these violations of the rules is very low, so it's not a real problem. What happens are these cutting over the with one wheel over the marking, and this I think is not very dangerous. Which might be dangerous is that the driver comes from the inner lane and goes out to the right lane. And we found this happens, not very frequently, and it only happens during situations where no other car is there. So it's also not very dangerous. Of course, we could not say loudly that not obeying the markings is not dangerous, but in fact it is true. It's not so bad if what happens in violation of the road markings. What it might be more severe are the speeds. On this critical entry, they have posed a speed reduction or a speed limit of 40 kilometers per hour on the approach, and you see why this distribution, nearly nobody is approaching with this speed, 25 meters in advance of the circle. So these speeds, let me say approaching with 70 kilometers per hour, they have no chance to stop in front of the roundabout. So this seems to be a very critical thing at this roundabout. We have also studied capacity, and inside the capacity equation we have this critical gap and the follow-up time, and we found out we must calculate the capacity for each lane separately. Here are the critical gaps and follow-up times which should be applied for these different types of entries. There is also again a software which can do it. Meanwhile, we have some more turbo roundabouts in Germany. This is one in Markdorf near the Lake Constance, and we see the left turners must use this lane, but then it's easy to turn to the left, so this would be a type which is typical for a high degree or a high proportion of left turning traffic. This is another one, a T junction, which has been converted into a turbo roundabout, and you see there are two turbo entrances, this one and that one, and a two-lane entry. Most of the traffic is going this way, and bypass was not necessary. It could be, all the traffic could be managed by this turbo entrance and turbo exit. Here are pictures from this installation. Here's another one, and here is one of the entrances. This is the one which is still under design, and you see this is a typical and good solution for such a turbo roundabout. Regarding geometric design, one could use the trick invented by Bertus Vertoyen in the Netherlands. The two circles on this side and that side should be staggered by 5 meters or by 1 lane width, and then all traffic is going on real circles. In the first approach in Germany we had something like egg lines or something, but by this tricky way of Bertus Vertoyen, this works quite well. And what's that? Safety. In this example in Baden-Baden, they started with not a good accident cost rate. This is the accident rate, this is the accident cost rate, but it decreased over the after 1 year, it was on a very acceptable level. We now studied all the turbo roundabouts in Germany, and we found out they seem to be the safest. So they are much below the 10 euros per 1,000 vehicles. So my conclusions are, it's an idea which is based on the policy to avoid large roundabouts in Germany. They work. Initially people were afraid they wouldn't work. It's capable to treat large volumes of through traffic under low demand from the side approaches. Cyclists and pedestrians should not be allowed on the turbo roundabout. We have no severe accidents, no fatality or no severely injured people, low accident cost rates. So turbo roundabouts seem to offer the potential to combine high safety, like on normal single-lane roundabouts with larger capacities. But anyway, the capacities will not become larger than 40,000 vehicles per day. So thank you for your attention.
Εδώ τελειώσαμε το πρώτο μέρος μας όσον αφορά τις ομιλίες. Έχουμε λίγο χρόνο για να απαντήσουμε σε ερωτήσεις, απορίες, παρατηρήσεις. Μπορείτε να εκφραστείτε και στα ελληνικά και στα αγγλικά. και τόσο οι μεταφραστές και όσο και εγώ θα προσπαθήσουμε να βοηθήσουμε σε αυτό το τομέα. Το βήμα είναι σε εσάς. Συνάδελφος.
Θα ήθελα να ξέρω ποιες μεθόδους περιορίζουν την ταχύτητα προσέγγισης σε κυκλικό κόμβο.
Για περαστικούς μιλάμε.
Για περαστικούς.
One question is for rural roundabouts. How we decrease the approach speeds before entering the roundabout, so that we don't have any persistent speed profile. It would be dangerous.
So on the circle, the speed of cars is around 20 kilometers per hour. If you make the roundabout quite obvious to the approaching drivers, then speed will normally not be a problem during daytime. During nighttime, of course, the driver might not be aware of this roundabout, and so it's very important to put these chevrons, reflecting chevrons on the center of the roundabout outside urban areas. If this doesn't work automatically, normally it works automatically. If there should be some problems, you of course would put on a speed limit, but as you have seen, speed limits sometimes are not very well obeyed, but usually the approaching speed is not a problem. Of course, sometimes such accidents could occur, as I have shown in one of the slides, but this is happening by drunken drivers or by people who are sleeping or driving and sleeping. And this happens, you must be aware of it. This happens 1 or 2 times per year, normally. And that's the reason why there shouldn't be there a dangerous obstacle, otherwise these people would be killed. And when they are running over the central island, and it's flat, or rather flat, and no stones and no monuments and so on, then it's not so bad. But usually speeding works quite well, but it's important in rural areas during nighttime you need these chevrons which have a very bright light and nobody would run in, normally people wouldn't run against this light.
Άλλη ερώτηση.
This road in Baden-Baden you showed us the roundabout. Was the main road the NKL3 design level?
This was something like a motorway. It was a secondary motorway, or it is a secondary motorway. It's a connection between the high-level motorway and the city center. And it always had a speed limit of 60 kilometers per hour due to noise reduction. And, but there was no intersection before, so this intersection was completely new. Now, due to this intersection, let me say the character of the motorway is ending at this roundabout. It's continuing in the old form, but then it has now the character of an urban street.
Άλλη ερώτηση.
Από όλες τις φωτογραφίες που είδαμε, για τα roundabouts, είδαμε 4 κλάδους. Προβλέπουν κάτι για το σχεδιασμό των κλάδων που θέσατε.
In the roundabouts configuration, mainly we show 4 legs, but about more than 4 legs.
If you have space enough, it's not a problem. Of course, with more than 4 legs, the size of the roundabout would increase. If you must make it possible that the entry is separated from the next exit, and they should both go to the margin of the roundabout, to the outer edge of the roundabout, and usually with more than 4 legs it might become a little bit larger, but the number of legs is not a problem. It could be 10 or more, but that would require a large ring. And of course you would have problems with signposting to guide drivers to the correct direction. That might become a problem because with a four-leg intersection, the driver can imagine where he should go. But if you have a larger roundabout and you are on the circle, you lose imagination where you are, and so signposting becomes critical. I should also say this for the turbo roundabout. Of course, I forgot it. For the turbo roundabout, signposting is very critical. You must make sure that the drivers are approaching the roundabout on the right lane. In the circle, they cannot correct it. So when they have entered on the wrong lane, they must exit to a direction which they don't want. So signposting for the turbo roundabout is very important. And my impression is you must have overhead signs to make sure for the driver that he finds this is my lane when I want to have this approach this destination. But there's some discussion if this should really be mandatory, this overhead signs. I think they must have overhead signs.
There's one question from Mr. Lipo. And this question has to do with the self-explaining road. You mentioned the self-explaining road as one that would need a minimum of signage for the driver to perceive the type and the character of the road or the highway so as to behave in the right way. Would you actually relate this to other nations' practices, and especially practices in this nation here concerning the driver behavior and the legal responsibility that will come out of such a self-explaining highway if you had to go into critical parts of that highway without signs or with a minimum of signs? I think I totally disagree with this. Probably in Germany, drivers are too low for it. That might be the case, but I don't think we do that in our driver population.
I mean that in every country the colleagues discuss the self-explaining roads in another kind. Yes. And it's right. Self-explaining is if you have automatically the right behavior. You know, as a driver, you know at the moment the correct behavior and the design of the road is self-explaining. But I mean only with the alignment and with the cross-section. You cannot reduce, for example, the speed behavior in this level, how it would be the good level in this case. The alignment, we have so large design elements that everybody can drive so fast like he wants. If you want to influence the speed behavior with the alignment, you must design very small curve radius, and then you have a very unsafety alignment, for example. Yes. I believe the difference in the speeds in the different design classes you can only get if you have an addition with traffic signs for the speed value. Or only with the alignment alone, it's impossible to create self-explaining roads and self-explaining road with different speed levels. Yes, but the correct behavior in special situations, for example, you have enough side distances, or you have a very good spatial alignment, and you have very simple traffic guidance in the junctions. This also is integrated in the word self-explaining road, but it's not the same like our standardized and recognizable roads, what we discuss in Germany.
I I understand there's a lot of legal problems.
Okay. I understand there's a lot of legal problems, and I think that they are in Germany, but in Greece, during the last, let's say, years, we have a lot of legal problems in public services because of the fact that the people understand and they demand that we have signage additional. Sometimes we are saying that signage, warning signage, okay, or informative signage exists, but they want more, up to the point where you can't understand why these people are so demanding. See? So we have everyday problem, and this happens not only to our rural roads or roads of, let's say, low classification, but roads of high design. See? And this is a great problem, really. You see? That's why I mentioned it before. There's also another observation about the question to Mr. Brindle about the roundabouts and whether you have 4 legs or 5 legs. We have been using techniques which in circumstances when these are possible, of course, because they are not always possible. Sometimes you have to have the 5 legs in the roundabout, and of course you will consider increasing the diameter or using additional length or whatever that is. But the point is that if you have 5 legs and you can extinguish one of the legs in one way or the other through using a cul-de-sac or using a unification of this before you reach the roundabout, then that's the way to do it, you see. And there are many cases with that. We can use a cul-de-sac, or we can use a unification, or we can use one-way streets, traffic management scheme, so we can take that direction of the roadway away from the roundabout, not to actually get into the roundabout. Thank you very much.
To some degree, I agree with you, but on an urban road, I think it's not frequent that you have 5 legs.
Whenever we have
on a rural road,
right.
In an urban environment, it might be possible. But we have also bad experience, you know, with the roundabout with 4 arms, and but there is a shopping center at the neighborhood, and the shopping center made it possible on a political way that they get direct access to the roundabout. And this turned always out to be very dangerous. This access to private ground, that turned out to be dangerous at roundabouts, because these roundabouts were not prepared for this additional entry, and so it was not something like artificial. But it would be a good policy if it's possible to avoid this 5th or 6th arm.
About the turbo roundabout. On the presentation there was a table showing the percentage of the 4 violating movements. Individual, every movement was more, like 1 to 3 or 5%. All the 4 movements had a percentage of 25%, which means for me that the 25% of the users of the roundabout were making some kind of violation. Adding all this together, isn't it a big percentage? Not individual movement, but all.
Yes, of course, it's a big percentage, but you know, these were violations where a driver touched with his with one wheel the marking, and not crossing the marking completely. And this happens. That was not a reason for any accidents. And I hope, or I would expect, that some enforcement would help. But you know, we have not too many policemen in Germany, and enforcement is a problem sometimes, so it doesn't happen. And yes, but anyway, we do not think that this is a reason to implement these curbs on the road. We think they are dangerous for motorcyclists. And of course, we have the problem of snow removal in most areas of Germany, and snow plugging on this type of intersection could become a problem. So we do not have the tendency to introduce a Dutch solution.
There's one more question for
There's one more question for Dr. Burden. How would you rate the capacity potential of the highway capacity manual methodology compared to, let's say, another empirical methodology such as Kimber's, the British? And how would you rate the single or double wing roundabout in terms of its capacity to a turbo roundabout, which you mentioned before, with the same characteristics and with the difference of the turbo roundabout?
I'm not sure that I understood the question completely, but let me say the Kimber equations from 1979, I think. My impression is they may apply in Britain, but they don't apply anywhere else. These produce much too high capacities. In other countries, these capacities have not been observed. Also in Britain, there are some publications which say this is a little bit doubtful. And for instance, they put in another part of capacity for each centimeter how you widen the road. But a centimeter or half a meter does not affect the capacity on the continental circumstances. So one additional lane would increase the capacity, but not 1 meter. And that's so. I haven't seen any proof that these equations would apply anywhere else. And when you say highway capacity manual, the equations in the new, not the old, in the new highway capacity manual, which will appear in the next months, these equations are based on measurements in America. By the way, we have made the evaluations of these measurements, and these capacities are much lower than on the European continent. So initially the Americans were a little bit angry on us because they said you must make something wrong if America has lower capacity than other countries, because America always must be the best one. But finally they found out, yes, it's true, because American drivers are driving very, very carefully, much more careful than we do on the European continent. And so what was found out in France, in Germany, Netherlands, and Switzerland is that we are somewhere in the middle between America and Britain. And so I think there are really cultural differences between countries, also regarding capacity of roundabouts, and these capacities must be calibrated for each country.
To this I agree partly with what you say, but I would point out that the British evaluation of capacity has come out of a certain practice which has probably resulted from an extensive use of roundabouts, which was not the case in the United States, because in the States they used the roundabouts and they started using it, as you said before, after the year 2000 and during the last decade. Probably we are much more up to date in the States than we were in Britain, but I think that the British practice has also been based on extensive research, probably during previous years.
These equations by Kimber have to a great part been calibrated by measurements on test tracks, not on real roads. Nevertheless, there might be, with test drivers, with hired students who are driving on this test track of the Transport Research Laboratory. But nevertheless, there might be, okay, in Britain, I cannot judge about that, but you should know the British have this offside priority rule, which I mentioned. And this offside priority rule has some miraculous consequences on the capacity. And this offside priority rule, that means there is a rule of priority on the circle, which the other nations don't have. In Germany, we don't have a rule who has priority if there is a conflict between two vehicles on the circle. And that makes it that the drivers have the tendency to drive on the right. Careful drivers all go on the right side. So the whole capacity which might be there is not exploited. And So if we would have British priority rules and the drivers would have learned this, we might also come up to the British capacities. But at the moment in Germany or on the Central Europe, we don't have a chance to come up with these British capacities. And what I heard from America is also, you know, British rules are rather popular in America, but some people have also made some bad experience with that, because the capacity do not show up in America like they are in Britain. Capacity of roundabouts in America are even lower than in Europe.
Thank you very much.
Ήθελα να σας ρωτήσω, στην Ευρώπη για την επόμενη δεκαετία μπαίνει στόχος για μηδενικά ατυχήματα στο ευρωπαϊκό δίκτυο. Στη χώρα μας ο δείκτης ατυχημάτων είναι πολύ ψηλός και οφείλεται σε ένα μεγάλο μέρος από τον τρόπο που κατασκευάζονται οι δρόμοι και ειδικά οι διασταυρώσεις. Δεν υπάρχουν προδιαγραφές για τους κυκλικούς κόμβους. Αν υπάρχουν στοιχεία για θανατηφόρα ατυχήματα σε κυκλικούς κόμβους στην Ευρώπη.
Basing his observation on the fact that in Europe we are starting tendency to vision zero on accidents, and his special interest is on roundabouts, whether there have been accidents registered that are fatalities. Do we have data about fatalities on roundabouts?
There are some, let me speak for Germany, there are some fatalities on roundabouts, but these accidents are known one by one, so they are very seldom. Sometimes these accidents are also suicides. I know two examples where the driver has left a letter to his wife, I want to make my end, and he ran with his car on the middle of such a rock on the roundabout. In the police records they are called accidents, but these are suicides. But there are also real accidents on roundabouts. I remember one where a bicycle driver was slightly hit by a car, but he fell with his head on a curb, so he was dead, immediately dead. So there are accidents, fatal accidents, but very, very seldom. And you see this comparison, 90% less fatalities compared to conventional intersections, and this was also found out in France. That was the reason why in France, you know, France everything is centralized, and they made, in the early 80s, they made experiments or researchers, they found out this figure of 90% reduction of fatalities, and then they decided we do not longer allow traffic lights on rural places. All the traffic lights on rural places are banned and replaced by roundabouts. And so roundabouts really have the systematically the way they reduce severe accidents tremendously. And the only road users who still have problems are the cyclists, and in many cases the cyclists also due to their wrong behavior. They drive the wrong way around the roundabout, and the drivers do not expect that bicycle drivers will come from the right when they enter. So cyclists are in risk. All the others, if everything is made correctly, of course, I didn't talk about details of curbs and radii and so on. You can make a lot of mistakes designing a roundabout. But when it's well done, then it's safe.
Νομίζω απάντησε και στο ερώτημα του προδιαγραφών του. Άλλο ερώτημα, ερώτηση. That's what I also do, one for roundabouts and one for the new German philosophy. Especially in rural areas, what is the importance, the role of the consistency of the roundabouts? I have observed cases or proposals here in the country, in rural areas, let's say in alignment or 30 kilometers length, that in the middle of the mountains, just roundabout, without any other, let's say, working out the driver to expect that, or he's accustomed with the configuration, the use of roundabout. So the question is, does it play an important role, or we can use it without any consistency or considerations on the configuration of the junction or the intersection? And to Mr. Lippert, what will happen with the old roads? So it is well recognized internationally that self-explaining roads is important for the driver to understand a good and correct driving behavior. That's the starting point for safety. So in this country less, but in your country more, you already have built up your road network. So if you introduce these new concepts, how do you fit them in the old one? Are you going to remark them, change the cross sections, whatever?
When you say there is only one roundabout and no other roundabout in the whole area, of course this one could be a problem. If there are several, then the drivers are a little bit experienced with that. But and of course, one roundabout after 50 kilometers of fast driving on a rural road might also become a problem, and you need some making the driver aware that something is happening here, and so some delineation of the approach might help, and of course in that case signs. But you know, usually these in Germany we have a policy on long distance roads. Roundabouts should be avoided, as we have seen by the presentation of Mr. Lippert, that on long distance roads, class 1 and 2, roundabouts are not recommended. Then traffic signals are preferred, hoping that the drivers on the main road must not stop at the traffic signal. The roundabout has the disadvantage that a driver must find his way in the roundabout. If you go on a very long distance on a two-lane road, and you know I want to go from Hamburg to Berlin, and I just must go straight ahead, then I find my way very easily. But if there are many roundabouts at each place, you must find the correct exit. So it's an additional task, and of course if these are truck drivers, they have problems to negotiate with the narrow curbs and turning radius, so on long distance roads, roundabouts should be avoided. That's the official policy. And but if you have only one roundabout and nothing else, this one might become a problem, of course.
So, of course, it's really a correct question. First, I would say self-explaining has to be a lot of different single situations. The alignment has to be self-explaining, the cross-section can be self-explaining, junction has to be self-explaining. You must to check, for example, black spots, they are not self-explaining, you have to reconstruct it. These are single situations. The combination of different standards to standardize and recognize the roads. This is really a new quality, a new level in the design of the road network. And our road network is in the most part finished. So it's clear that this is a process for the next 20, 30, 40 years, and perhaps also longer. And the main task is also to adapt the idea of the standardized and recognizable road on the existing road network. And for the driver is the most easy to recognize the marking. This is the first step. To adapt the marking, if it's possible, if you reconstruct your road surface, for example, or you have to to make use of marking lines, that you adapt the new ideas of the marking on the existing roads. The next steps are to regulate the overtaking, perhaps with the reconstruction or the construction from additional overtaking lanes. And the next step, a little bit longer and most expensive, to reconstruct new junctions and two levels, for example. And at the moment, we also develop guideline in addition to the guidelines for the rural roads, and a new guideline for the existing road network to adapt the ideas from the RAL on the existing road network. And this, it's clear, it's a long process.
Thank you. Εφόσον δεν υπάρχουν άλλες ερωτήσεις, μπορούμε να προχωρήσουμε στο διάλειμμα. Μισή ώρα.
Νομίζω δεν έχουμε μείνει πολύ πίσω. Μισή ώρα διάλειμμα, μόνο και για δικιά μας και για δικιά σας ευκολία. Μπορείτε και στο διάλειμμα να πάρετε το CD με τις 7 εισηγήσεις και όποιος θέλει βεβαίως να πάρει και βεβαίως που παρακολούθησε το σεμινάριο.
Έλα, μόλις έγινε διάλειμμα. Τώρα, για δες το. Δες το. Τώρα, εδώ είναι το καλύτερο. Να είναι καλά, αξιολογότατος. Και είχε μία μεγάλη απουσία. Ήταν από τα πιο πέρσι πρόπερσι.